Now we're going to look at another type of asymptote called an oblique or slant asymptote. We've looked at the three different cases for finding the horizontal asymptote. When the degree of the numerator is larger, we state that there is no horizontal asymptote. Now this is true, but there exists a different type of asymptote for this function. If the degree of the numerator is larger by 1 power, then I will have what's called a slant asymptote, which will be represented by the equation of a line. If the degree of the numerator is larger by more than 1 degree, then I will have no horizontal and no slant asymptote. So again, anytime the degree of the numerator is greater by the degree of the denominator by 1 degree, so they can only differ by 1 degree, then there will be an oblique or slant asymptote. So as you can see in this graph, an oblique asymptote, or sometimes called a slant asymptote, it looks like a linear function and it will be represented by the equation of a line. To find the equation of the oblique asymptote, we are going to have to do some long division. So let's recall here, the top here is called my dividend, and this guy is going to go underneath the division bar. The bottom is our divisor, and it goes on the outside. Now when I do long division, I must have placeholders for anything that is not represented. So when I put my divisor on the outside, I have linear constant, so that's fine. But my dividend only has a quadratic, no linear term, so I have to represent my linear term, and then my constant. When doing long division, I ask myself, x times what gives me x squared? Or x squared divided by x is what? Now that's going to be x, so I line that up with my linear term underneath. And then I'm going to multiply that back through, so that's x squared minus x. Remember, we are always subtracting. Put your parentheses here. So that will give me 0. 0x minus negative x is a positive x. Bring down the positive 3. X times what gives me x? Or x divided by x is what? Well, that's going to be 1. And then I multiply that 1 back through. So I'm going to get x and then negative 1. Subtracting, I get 0. 3 minus negative 1 is 3 plus 1, which is 4. Now remember, we only want the polynomial part of our quotient, which means my oblique asymptote will only be represented by this part up here. I ignore the remainder. So my oblique asymptote will be y equals x plus 1. I know you are just burning with the question as to why we ignore the remainder when finding the oblique asymptote. Well, let's analyze the three different cases. When the degree of the numerator is smaller than the degree of the denominator, we cannot do any type of long division. Therefore, our remainder is 2 over x plus 1, and our quotient is just 0. That means our horizontal asymptote is y equals 0. When the degree of the numerator and the denominator are the same, we know the trick. We just look at the coefficients, right? Well, if I were to do some long division, you could see that the quotient ends up being 2 with a remainder of negative 2 over x plus 1. So again, we ignore that remainder and we just look at the whole number quotient. Now, when the degree of the numerator is greater, we know we do not have a horizontal asymptote. And when you do the long division, again, your quotient ends up being a linear function with this extra remainder. So we are just going to focus on the polynomial part of that quotient and ignore the remainder just like we have been for all the other cases. Now I want you to find the oblique asymptote of this rational function by using long division.